All right, welcome to this video on solving linear systems by elimination. So this is the lesson on it. We did solving linear systems by graphing, so you now understand that when you're solving two linear systems, it's about finding the point of intersection, or POI. And you're going to hear me say that or see that several times throughout this lesson, okay? Now, often when we're solving by graphing, it's a little challenging. Graphs can be difficult. It could be really difficult if the answers weren't integers. In other words, like what if the answer was 2.5 by 3.25? Then it becomes really hard. The graph has to be really well drawn, and you have to do some guesstimating. And so we like to try to find alternate methods that don't require us to graph. And so this is the first method. The other method will do the same thing. And this one is called elimination, and we don't need to use graph paper. What we're going to do is we're going to add or subtract the two equations to eliminate one of the variables, hence the term elimination. Okay, so we're going to add or subtract the two equations to get rid of it. Now, it works absolutely really good when both equations are given in standard form. Okay, so all the questions that you get that work for elimination, I kind of give in standard form. Okay, remember, standard form is where you have x term, the y term, and then it equals a constant. Doesn't come in slope intercept form. Okay, so this method works really good if both equations are given this way, because we don't really have to manipulate or change the equations in any way. So what I'm going to do is I'm going to just do a whole bunch of examples, because I think it's the easiest way for you to learn how to do this. Okay. Now, the first thing we do when we're solving by elimination is we name our equations. We did this the last time as well. We give them a name, and I'm going to be really boring and always use A and B, but you can name them anything you want. I've been known to sometimes name my equations after my ex-girlfriends just for fun. But for today, on the video lesson, I'm going to stick to A and B. So this one here I'm going to call A, and this one I'm going to call B. And when we solve equations like this, we want to eliminate one of the terms. So we look for two terms that are the same value. So I have 2x and I have minus 2x, and that is an indicator I like that. Whereas I have 3y and 5y. If I was to add these two, I'd get 8. If I was to subtract, I'd get minus 2, so that's not going to work for me. But if I add these two here, I'm going to get 0, and I like that because it will eliminate the term for me. So what I'm going to do is I'm going to take A, and I'm going to say equation A subtract equation B. Okay, and sorry, I apologize. We're going to add, because this is a negative and that's a positive. And if we take plus 2 and add minus 2, we end up at 0. So sometimes we'll just draw a line right here, and we're going to add them. This will be 0, right? 2x plus minus 2. 3y plus 5y equals 8y. And 6 plus 10 is 16. So the 0, it's gone. We don't have to worry about it. It's out of there. It's not a problem for us, okay? And what we have left is 8y equals 16. I can solve for what y is. Simply divide both sides by 8. And I have y equals 2. I have now solved half of my solution for my point of intersection. I know that the y value of my point of intersection is 2, but I don't know what the x value is. Well, what we like to do is kind of swing up here. Sometimes I even go like this and draw a line, but you don't have to do that. I say substitute y equals 2 into, and I'm going to sub it into either one of these two equations. I can pick either one. Now, I'm going to be honest. I usually pick the equation that has the smaller numbers, and sometimes the ones that don't have a lot of negatives. I don't know. I just find that when there's negatives involved, I'm more likely to make a mistake. So I'll avoid those. So in this case, I'm going to pick equation A. It just seems to make more sense because it doesn't have a negative and it it has smaller numbers overall. So into A. So what that means is I'm going to write out A, and wherever there's a Y, I'm going to put a 2 because Y equals 2. So I go 2x plus 3. Now it's not Y, it's going to be 2. And I always put them in brackets, equals 6. And this tells me this has to be multiplied. So this means that 2x plus 3 times 2 is 6 equals 6. Now I'm going to solve for what x is. Subtract 6 here, subtract 6 here. That leaves me with 2x equals 0. Wow. What's x equal? Well, divide both sides by 2. Divide by 2. X equals 0 divided by 2 is 0. And now I have my x value and my y value. And all I have left to do is write my therefore statement, which is therefore the POI is, in its bracket, because it's an ordered pair, 0 for the x, comma, 2 for the y. All done. I have my solution for these two lines. I know that these two lines intersect at the point 0, 2. If I was just do a little sketch of graph, just pretend that this is an x and a y right here. That means if I go on x 0, y 1, 2 right there, there's two lines. I don't know where the lines go. They go like this and like that, but they cross right there. That's where they intersect, and that's all I care about. I'm not really worried about where the lines actually go. I'm just worried about where they intersect. Let's do another example because there's a lot of little twists and turns that go with these. So I'll do another example here. I'm just going to erase this mess over here, put my pen back on. So once again, first step, identify or label my lines. Okay, so in this particular case, A and B. Now, when I look at my equations, I have an x and an x. I have a 3y and a minus 3y and a positive 1y, a 9 and a 1. That part's not as important. I want to figure out how I can eliminate one of these two terms. Well, the x's are of equal value. They're exactly the same. So that means if I subtract them, I'd have 0. So if I went x minus x, that would be 0. So what I do is I say a minus b. Okay, and I always, when I'm doing these, I circle the A and B, and that's to make sure that they're not confused to be a variable. Okay, that's part of the reason why I do that, is circle them just to say that's not a variable. So don't get confused or anything. It's just my way of distinguishing between the two, and a lot of math people do this. So x take away x is 0, minus 3 minus 1. Oh, minus 3 minus 1. That's actually going to be minus 4y equals 9 subtract 1. Well, that equals 8. Now I want to solve for y. Well, I divide by minus 4, divide by minus 4, and I have y equals minus 2. Minus 4 divided by minus 4 is 1, and 8 divided by minus 4 is minus 2. So once again, I have half of my answer. I have my y point, part of the point. I need to get the x. So what I do is I say I'm going to substitute y equals minus 2. By the way, I often do this, like point up there. And the only reason I'm doing that, I could just keep working down below, but I'm kind of utilizing my space that I have available to me. It's just my technique. Nothing special about it. And I'm going to substitute this into A or B. And it clearly B is a much easier equation than A. It doesn't have negatives and it's got smaller numbers. So I'm going to say into B. And so then I write X plus, and now where there's a Y, I'm going to put minus 2 equals 1. And in this case, I want to solve for X. So I'm going to I'm going to add 2 here to make that 0, and I'm going to add 2 here, and then I'm going to get X equals 3. Now I have my 2 values of my point of intersection. So therefore, the POI, point of intersection, is X always comes first, 3, and Y always comes second, minus 2. And again, if I was just to visualize for a minute what it would mean if I had a graph of Y and X would be 3, 1, 2, 3, and Y would be minus 2, would be down here. Okay, and that would be where my point would be. Okay, and that would basically mean the 2 lines would kind of cross right at that point. I'm not very good at drawing my lines there, but I think you know what I mean. Okay, so another example. Let's move on, do a little bit more complicated. So we did the first one we added the 2 lines to eliminate. The second one we subtracted the 2 lines to eliminate. Now we're going to have to add another step in order to eliminate the lines. Okay, so what I'm going to do here, same thing. I'm going to start very much the same way. Okay, just going to get my cursor out of the way here. And what you're going to find is that I label this A and this B. Now, it's a little difference here. I don't have an X and an X and a Y that are of equal or opposite value. So therefore, I can't just add or subtract and get rid of something. I have to do something here. But if I multiply the B or the Y by 2 and make this 2Y, then I can do that. But in order to keep the equation intact, to keep it true, I have to multiply everybody, not just the Y, but every single term by 2. And as long as I multiply both sides of the equation completely by 2, I don't change the equation. So what I do is I go 2 times B. And I'm going to call 2 times B means 2 times every term in the equation. So this becomes 2x plus 2y equals 12. And now I'm going to write A again, okay? And this is where kids get lazy. They don't want to have to do this, but you really should, okay? Just rewriting the equation down equals 6. So 4x minus 2y equals 6. Now I see I have a positive 2y and a negative 2y. Oh, I like that because now I can add these 2 equations and that will eliminate my y term. So I have to write this here. I have to say 2b plus A. And by the way, writing this stuff over on the side is part of your marks. If you don't do this, you will lose marks, okay? You have to tell me what you're doing as you're doing it. You can't just randomly do things and not say what you're doing, okay? It's sort of like this is your guide telling me what you're doing, okay? Now I'm going to add, well, what's 2x plus 4x? Well, that's 6x. What's 2y plus minus 2y? That's 0. I don't even need to write that if I don't want to. And then I go 12 plus 6 is 18. So I have 6x equals 18. How do I solve for x? I divide both sides by 6. That gives me x equals 3. And I now have 1/2 of my solution. I now know that my ordered pair starts with a 3 because the x value is a 3. Now I say sub x equals 3 into, and I can pick which one is easier. Well, I think most of you will quickly see that B is much simpler. So I'm going to choose B. And always going back to A and B, folks. I'm not picking one of these ones down here. I'm always picking from A or B, okay? So now I'm going to substitute that in. Well, where there's an x, I'm going to put a 3. So that's going to be 3 plus y equals 6. Well, I want to find out what y is. Well, minus 3 minus 3, y equals 3. So therefore, the POI is, and it's the ordered pair, x is 3, comma, y is 3. And you'll notice it's always an ordered pair that I'm getting for an answer. Okay? This is about the most difficult kind of questions that I'll ask students to do, but I wanted to show you a more challenging one, just as a sort of a follow-up. What happens with it? You get these ones sometimes where the x values don't match up and the y values don't match up. And what's really funky is I can't even just multiply the y. What do I multiply by 2 by to get to 5, or 3 to get to 5? I can't. So watch what I'm going to do here. I'm going to choose a little different method here. I'm going to call this A and this B. That's the exact same thing. But this time what I'm going to do is I'm going to say I want to eliminate I'm going to eliminate the y's. So what I'm going to do here is I am going to multiply, sorry, I'm going to eliminate the x's. Let's go for the x's. Okay. I am going to multiply a by 5. Okay. I'm going to go 5 times a. That means everybody in a gets multiplied by 5. 5 times 3, 15x. 5 times 2 minus 10y, and 5 times another 2 equals 10. And then I'm going to multiply this one by 3. And you'll say, well, why 3? Well, you'll see here in a second. 3 because 3 times 5 is 15x. And look at now, I now have equal values, so I can subtract these two, okay? And I'll have minus 3 times 5 minus 15y equals 3 times 10, 30. And what I'm going to do is I'm going to say 5a minus 3b. I'm going to subtract these two now. I'm going to subtract. Okay? And 15 minus 15 is the big 0. 10 minus 15. Oh my goodness. Minus 10 minus 15. Well, believe it or not, if you put that in your calculator, negative 10 subtract negative 15, you're actually going to come up with the answer 5. So it's 5y. And this is where it gets kind of tricky with all these signs and stuff to keep track of. But basically you have two negatives, which turns into a positive. So it becomes minus 10 plus 15, and that's how we get to 5. And then here we have 10 minus 30, which is minus 20. All right. Oh, my palm's making a mess over here, so I'll do some erasing. We now are very close to getting the first half done. Divide by 5, divide by 5. Y equals minus 4. All right, I got half of the question done. So now I say sub y equals minus 4 into, and I can pick A or B. And I really don't see a lot of difference. I think A has slightly smaller numbers, so I'm going to go for A. And then I get 3x minus 2 times minus 4, because I'm now changing the y for minus 4, equals 2. This is 3x minus 2 times minus 4 is plus 8 equals 2. Subtract 8 here, subtract 8 here. This gives me 3x equals minus 6. Divide by 3, divide by 3. X equals minus 2. There's my two values. Y equals minus 4, x equals minus 2. And that gives me a therefore statement. Therefore, the POI, point of intersection, is -2 minus 4. Notice how I put the x value first, the y value second. That's how ordered pairs work. You would have learned that probably somewhere around grade 7 or 8. You cannot deviate from that. That's just the way it goes, okay? All right, that's the lesson. Now I'm going to give you a little heads up here on your worksheet. When you go to do your worksheet, okay, which is the file that says WS on the end, numbers 1 to 16 is all I'm asking you to do, okay? If you choose to do number 17 to number 24, that's yours. That's your option. The question I just did is actually number 20. So I just did the example from number 20, but I'm not asking students to do that, and I won't test you on that. All right, enjoy your day.